Continuing on the first page of 5.2, and we have example number 22 from page 307. And we're just going to follow the same steps again as we look at the two equations. The top one, x plus y equals -1 equals 2 times parentheses y minus x. The second equation is y equals 3x minus 1. What's different about this system, as it looks more complicated, really just has yet to be simplified on the top. So that's one thing we will get to do here as part of this, is just to simplify the top. And our first step still applies: solve one equation for one variable. So that one is actually done for us again. The second equation is already solved for y. So that part's done. So our next step will be to substitute in the other equation, but I think we'll clean up this top one first here. So just over to the side, I'm going to go ahead and clean up or simplify the first equation to make step 2 easier. And simplify means that we're going to combine like terms and take care of any parentheses by distribution here. So on the left side, I get x plus y minus 1 is equal to, distributing that to 2y minus 2x. From here, I'm going to go ahead and leave some workspace so that I can substitute in for y. So x plus y minus 1 equals 2y minus, 2 times y minus 2x. Okay, and then we'll go ahead and substitute in our 3x minus 1 into our two spots here. So this becomes x plus 3x minus 1 equals 2 times 3x minus 1 minus 2x. I've just replaced the y values with the second equation for y. Thus the name substitution. From there, we want to work through what this will equal. On the left side, because now we're at step 3, we're solving for one of the variables, and that's just going to be solving for x. So this was step 2, here was the substitution. And now step 3, I get x plus 3x minus 1 equals, distribute the 2. 2 times 3x is 6x, 2 times -1 is a minus 2, minus 2x. Combine like terms, x plus 3x is 4x, minus 1 is minus 2. On the right side, 6x minus 2x is 4x minus 2. And right here, we might notice that both sides are equal. But if you didn't happen to see that at that point, you could go ahead and keep solving. Subtract 4x from both sides, trying to get x on one side or the other. If the x's fall out, you're left with a true statement, -2 is equal to -2. If you took that one step further, tried to add 2 to both sides, it would equal out to be 0 equals 0. This is a true statement. Anytime you solve an equation, you could recall this from Math 60, when we were solving inequalities or equations and all the variables dropped out and you were left with a true or a false statement. In this case, true, 0 does equal 0. That means that anything you plug in works in this equation. Well, if anything we plug in works in this equation, that means that we have the same line. You have an infinite number of solutions here. So here's a situation where we get to use our infinite number of solutions. So in our process of trying to solve for one variable, everything fell out, and so we've got a true statement, which means that it's the infinite number of solutions. And in set notation, what that looks like is the braces here, and you would write it as all points x, y, such that, the straight line means such that, And then you could use either equation. So you could use the bottom one is the cleaner one. That might be nice to use, okay? But you can use either one. You can use either equation, okay? And then if it had turned out to be a false statement, that would be the other option where it's no solution or parallel lines. So take a moment to really get this solid for yourself. Make sure you've copied the notes completely. Note any questions you have. Bring them to your source of help or to class. And then make sure you talk this through. What happened here? Talk through the steps. Make sure you understand and not just blindly follow the numbers and the things that's been written. If you can talk it through and really convince yourself or someone else, you've really got this material. Now would be a good time to pause the video and try number 14 at the bottom of the page on your own. Again, using substitution method because that's the section we're in. So pause the video, and then when you come back, you will see the solution. When you do solve this, the variables fall out again, just like in the one above, but this time you're left with a false statement. So instead of there being an infinite number of solutions, it's the exact opposite of that. This is a no solution situation, which means that they are parallel lines. And the symbol for that is the two straight up and down